Welcome students. We want to discuss about the cross product. Before we go further, note the following quote by Sophie Germain. She was a French mathematician, quite famous French mathematician. Algebra is nothing more than geometry in words. Geometry is nothing more than algebra in pictures. So this is quote by Sophie Germain. She was a algebraist and number theorist. There are primes which are named as Germain primes. Okay, so we want to study the cross product now. So the idea is in last class, we discussed about quote unquote multiplying two vectors in a way or taking product of two vectors and getting a scalar. Now we want to have product of two vectors, which is also a vector. And that one of those things is cross product. Again, we are not forcefully defining this. It has a lot of cross product has a lot of applications in physical sciences. Uh, we'll see some of them at the end of this lecture. So the following is a motivational problem. So find the area of the parallelogram determined by vector A and B. So you are interested in, so you have vector A and you have vector B, and we want to find out what is area of this parallelogram. Yeah, so we are interested to know what is the area of this parallelogram, and we'll see the connection with the cross product soon. So first of all, what is a cross product? Cross product is a vector product. Well, because the cross product of two vectors is a vector, so hence a vector product of two vectors, A, which is given by A1, A2, A3, B, which is given by B1, B2, B3, and is defined by A cross B, which is A2, B3 minus A3, B2, A3, B1 minus A1, B3, A1, B2 minus A2, B1. So this is an algebraic definition of cross product. Now, easy way to remember cross product is via determinants. So A cross B is going to be, so you write it as I, J, K, A1, A2, A3, B1, B2, B3, and you compute determinant of this. So this thing is a determinant of the matrix inside. Now, this is quite a peculiar matrix. Why? Because the entries of this matrix is so these are real numbers, whereas this is a vector. So how we'll do the matrix determinant computation formally? So the one way to do that is put plus minus plus. So you take this is equal to I times, you write the sub matrix. The sub matrix is obtained by ignoring or covering up this column and this row. So what is left out is this part here. So I'm going to write that matrix down. So I'm going to write A2, A3, B2, B3. Okay. Okay. Now with the minus sign here, so minus J times. Now again, in that case, we'll cover up this guy and this guy here. So what is left out? A1, B1, A3, B3. And then you have plus K hat times. Now in this case, you have to hide these guys and write down the subdeterminant obtained here, which is going to be A1, A2, B1, B2. Okay, so now this is going to be I times Now, this can be written as A2. So what is the determinant of 2 by 2 matrix? So determinant of 2 by 2 matrix A, B, C, D is AD minus BC. So this multiplied by this minus this multiplied by that. So here we'll get A2 B3 minus A3 B2 minus J times A1 B3 minus A3 B1 plus K times A1 B2 minus A2 B1. And then if you write it in, so instead of ijk form, if you write it in the vector form, you'll get A2b3 minus A3b2. This minus will basically make this minus this plus. So we'll just write it in the slightly different order. We have A3b1 minus A1b3, comma A1b2 minus A2b1. And you see that this definition matches with this. So this is a cross product of two vectors, and as you can see, it is a vector as well, yeah, with three components. Now, note, you can directly write it down as follows. So you have, if you can recall the first one, then you have to replace 2 by 3, 3 by next one, which is 1. So you are basically going in the following order: 1, 2, 3, 1. So if you go in this order, if you know the first one, you can write down all, right? So for example, A3B1, when it goes here, after 3, you get what? 1. And then after 1, you get what? 2. And then similarly, after 1, you get 2. After 3, you get 1, right? So this order. So there's a lot of structure in the cross product. It's not without structure, all right? So that is the cross product of two vectors. Okay, all right. So let's compute the cross product of these two vectors. Now, which one shall we choose? I will choose the determinant one because it's easier to recall. So A cross B is going to be I, J, K, caps on top of them because they're unit vector, 5, 7, 0, minus 3, 4, 2. This is going to be I times 7 minus 2 minus 4 minus 0. So 7 times 2 minus 4 times 0. So plus minus plus minus j times, yeah, so you see plus minus plus. So j has a negative sign. So j times, now you ignore this one and this one to see what do you get. You get 5 minus 3. So 5 times 2, which is 5 times 2 minus 0 times minus 3 plus k times, now you write down 5 times 4, which is 20, minus of minus, which is plus 21. And when we write it down, we get 14i. Generally, it's customary to write I after the coefficient, minus 10j plus 41k. And if you want to write it in the other format, it's going to be 14 minus 10, 41. So this is a cross product of these two vectors. Now let's show that A cross A is 0 for any vector in V3. So now there are many ways to look at it. One way to look at that is A cross A is same as I, J, K. You have A1, A2, A3, and B1, B2, B3. sorry, we have both of them are A1, A. So A1, A2, A3. And note that determinant is 0 if two rows are equal. So either that way, you can think about it that way, or you can really multiply it out. So I times, now we have A2, A3, this minus this. So A2, A3 minus A2, A3 minus J times what? J times A1, A3 minus A3, A1 plus K times, now you have A1, A2 minus A2, A1, and these are equal, so you get 0i minus 0j plus 0k, which is essentially 0 vector, and which is also given by 0 as a vector. Okay, so this is the setup. So this is says that a cross product of a vector is with itself is 0. Now, what can we say about the physical interpretation of the cross product? How does it looks like? So the idea is the following: the cross product of vector A and B is perpendicular to both A and B. So A cross B is perpendicular to both A and B. So how would we show that? Well, one way to show that is to take the dot product of A cross B with A and show that that is equal to 0, right? Because we have seen in the last class that dot product of two vectors which are perpendicular is 0. So let me write down. So to show that A cross B dot with vector A and A cross B dot with vector B both are 0. That will basically prove that A cross B is perpendicular to both, right? So how would we prove this? So we'll take a dot product. So I'm going to use the previous result, although determinant would have been easier, but let's use the previous result. So what is A cross B? So I'm going to copy A cross B from here. Okay. So what is A cross B? So A cross B is going to be, so let's show one. So A cross B dot with A is going to be, so what is A cross B? A cross B is, now I'll write it down, A2 B3 minus A3 B2. Okay. Now once I have the first term, I can write down the next one. So I'll replace 2 by 3, 3 by 1. So 2 by 3, A3 B1 minus A1 B3, comma, next one would be after 2 it will be A1 B2 minus A2 B1. Okay, so this is one way to remember it, all right, again. And then dot with what? A, which is A1, A2, A3. Now let's multiply it out. So we have, this is going to be A2 B3 minus A3 B2 times A1 plus, so this guy multiplied with this, then A3B1 minus A1B3, that is same as saying this guy multiplied with the second one, right? That's how the dot product goes, right? Times A2 plus A1B2 minus A2B1 multiplied by A3. So let's expand this out. So this is going to be A1 A2 B3 minus A1 A3 B2. I'm just multiplying it out. Plus A2 B1, sorry, A2 A3 B1. So I'm just multiplying it in the front. A3 B1 minus A2 A1 B3 plus A3 A1 B2 minus A3 A2 B1. Now let's see if we can cancel off terms. So A1 A2 B3. So this guy goes with A1 A2 B3. Similarly, this term will go with A1 A3 B2, A1 A3 B2, and then the last one will go with this. So the answer, the output is 0. So this is done. So similarly, you can prove the other one as well. So now it is easy to find a vector. It's easy to find, do this problem. Find a vector perpendicular to the plane that passes through 1, 2, 3, and 1, 0, 1, and 2, 1, 1. So let's call this as P, Q, and R. So you take P, Q, and R. You will have a unique plane passing through these. So what you do is you take the vector in PR. This will be perpendicular to the vector, to the plane passing through, the plane passing through. This is your plane, right? So plane passing through P, Q, and R, right? So because it says a vector, right? I mean, any scalar multiple of this vector will also be perpendicular. So a vector means you have to produce any vector. So for that, so after this observation, I should write PQ cross PR is perpendicular to the plane containing PQR, right? So now we have to compute PQ, PR. So what is PQ? So PQ is going to be Q, OQ minus P, or it's going to be 1, 0, 1 minus 1, 2, 3, which is going to be 1, so 0 minus 2 minus 2, and PR is going to be PR, which is 2, 1, 1, right? This is simply OR minus OP, if you recall, right? So this is going to be 2 minus 1, 2, 3, and that is going to be 1 minus 1 minus 2. So therefore, PQ cross PR is going to be, again, computation of this cross product, IJK. Again, I use IJK form because it's easy to work it out. You don't need to memorize anything. PQ, which is going to be 0 minus 2, and then 0 minus 2, and then minus 2. And then we have PR, which is going to be 1 minus 1 minus 2. So this is going to be, again, I times what is left out. So minus 2 minus 2 minus 1 minus 2 minus j times 0 times 0 minus 2 1 minus 2 plus k times 0 minus 2 1 minus 2. Okay, so this is going to be I times 4 minus 2, which is going to be 4 minus 2 is going to be 2. So I'm going to write down directly 2i. So this is going to be minus 2 times, so plus 2j, and then here plus to k. So this vector is perpendicular to both, is perpendicular to both, to both, to perpendicular to uh, to p, q, and to the plane containing p, q, and r. So this is the story. Now, what is the physical significance of cross product? So A cross B equals to length of A. So if you take A cross B, then it's basically a vector, right? But if you take the length of A cross B, that's A, length of B sine theta, where sine theta is the angle between the positive direction of A, where theta is between 0 and pi, right? So you're looking at the smallest angle between the positive direction of A and B, vector A and B. So this is the what the cross product represents. Now, again, so what is the direction given to this? So the direction of this cross product. So cross product is a vector. So of course the magnitude here is AB sine theta. What about the direction? The direction is given by right hand rule again. So what is the direction of A cross B? Direction of A cross B is take vector A, take your right hand, curl it from vector A to vector B in the direction, then the direction of your thumb points the unit vector along which you have uh, A cross B. So in particular, if you want to write A cross B, then it is length of A, length of B, sine theta as above, but the direction is given by this unit vector n, where n is given by what? It's a unit vector in the direction of your thumb if you curl your finger from vector A to vector B. All right, so this is the cross product. The proof of this is slightly algebraic in nature. So to see the proof of this, we will have to do a little bit of algebra. Namely, let's look at this. So A cross B, what is the length of this? So generally we are interested in length square. That is going to be, length of this is going to be, length of a vector is the component squared, right? So A cross B is going to be, the whole square is going to be this square plus this square plus this square, right? So let's write that down. So this is going to be A2B3 minus B minus A3B2, the whole square, plus A3B1 minus A1B3 whole square, plus A1B2 minus A2B1 the whole square. So now let's expand this out. So it's going to be slightly tedious, but nevertheless, A2 square B3 square plus A3B2 square minus 2 A2B3 A3B2 plus A3B1 A3 square B1 square plus A1 square B3 square minus 2 A3B1 A1B3. Okay. And this is going to be, the next term is going to be A1B square B2 square plus A2 2 square b1 square minus 2a1 b2 a2 b1. Now, if you rearrange this, this can be written as, so you have to do a little bit of work. You will see that this can be written as a1 square plus a2 square plus a3 square times b1 square plus b2 square plus b3 square minus 2, so minus a1 b1 plus a2 b2 plus a3 b3 the whole square. Okay, so you have to do that simplification. So this is simply length of a square times length of b square minus inner product, so dot product of a1 dot a2 the whole square, so vectors. Now you can expand this part. So this is going to be length of a1 square, length of b1, sorry, length of a square, length of b square minus, now what is a dot b? It's length of a, length of b, cos theta, then the whole square. So if we pull out, if we pull out, if we pull out length of a, length of b, the whole square out, what is left out? 1 minus cos square theta, and that is sine square theta. So which is going to be length of a, length of b, let's write it in one, length of b sine theta, actually sine square theta, but I can write this as whole square. So if you take square root on both sides, it will give you the result, taking square root on both sides. Gives you result. Okay. Again, you have to argue that the sine theta is going to be positive. You're taking the positive square root. So here it is. So we have a cross b equals to, so if you take that, you get a cross b equals to length of a, length of b sine theta. So this clearly means that, so a cross b, length of a cross b is length of a times length of b sine theta. This is 0 if and only if what? If, so a and b are non-zero vectors, right? So these are non-zero vectors. So this is only if sine theta equals to 0, since a and b are non-zero vectors, so their length cannot be 0, right? So, and that means what? So what is your theta? So theta is between what? 0 and pi. So this would mean that they are parallel. So this implies theta equals to 0 or pi, implying they are parallel. Yeah? Or if you want to use, they are parallel or anti-parallel. All right. Now, so what does the cross product represents? So cross product of AB, vector A, vector B, represents the area of the parallelogram determined by vector A and vector B. Now, why is that the case? So if this is a vector A and the other one is vector B, then this part is given by length of B sine theta, right? So in that case, we get, so because this length is given by length of this part, so length of this part here, so this part has length of vector B, and if you use trigonometry, sine theta equals to the height h, let's call this as h opposite side upon length of B, or this gives us basically that h equals to B, length of B sine theta. So therefore, what do we get? Therefore, area of the parallelogram is area is base times height, or actually proper way is to say length of base times length of height. Base is of length vector A times height is vector B, length of vector B sine theta. And if you look at this, this is going to be A cross B. So this is a physical interpretation of the cross product. So if you take the length of the cross product, it basically is the area of the parallelogram whose sides are spanned by vector A and vector B. So this gives us a way to find out the following. Determine the area of the parallelogram determined by vector A and B. So we have first, let's compute A cross B. So A cross B is, again, I'm going to use IJK formalism. You can use directly the algebraic formula. So 304, 043. Now that is going to be I times, now I'm going to write the solution directly. So minus 16. So minus 16 I j. So we have 9. So minus 9j. And then k 12k plus 12k. So therefore area equals to length of this guy, which is going to be length of 16i minus 9j plus 12k, this vector, which is going to be square root of 16 square plus 9 square plus 12 square. Okay, so this is the area. Okay, what about the answers? Now there are few more properties of cross product. So namely, A cross B is minus B cross A, so it's anti-commutative. Well, that is not hard to check. Suppose you have A cross B, then it's I, J, K, A1, A2, A3, B1, B2, B3. Now, if you swap these two, the determinant, if you swap if you swap two rows in determinant, it gets a negative sign. So minus I, J, K, B1, B2, B3, A1, A2, A3. If you're not comfortable with the swapping of rows in determinant, then you can work it out algebraically using the formula given on the top here, right? And you will see that it is indeed, this is same as minus of vector B cross A. So cross product is not commutative. We have A cross B plus C is A cross B plus A cross C. So this is what is called as distributivity of cross product over vector addition. Similarly, you have CA cross B is C of A cross B. Now A cross B, A times B cross C is going to be A cross B dot C. So this is also called as triple product. So we'll see that in a minute. And then another result is A cross B cross C is AC B. So A dot C times B minus A dot B times C. So all these things can be proved by one way would be to do component by component analysis. What is the ith component, what is the jth component, and what is the kth component. And you can see that they will be equal. Now, out of these, this one is of interest to us. I mean, all of them are interest to us, but this is of special interest to us because this is what is called as triple product. So what is the triple product? So A dot B cross C is called scalar triple product of vectors A, B, and C. So this is what a scalar triple product is. Sometimes it is also denoted by, you write A, B, and C. Now note that this is also equivalent to, not hard to see, that A cross B, so this is equal to, if you move any cyclic movement, you'll get the same. So you get B, C, A, and that is same as C, A, B. So these are equivalent. And the way to see that would be to see so this corresponds to how many interchanges in the determinant. So it will correspond to two row changes in the determinant, which will basically so if you do even number of row changes in the determinant remains the same. Or otherwise, you can work it out algebraically. Now, there is a physical significance of triple product, namely the following. So volume of a parallelepiped. So parallelepiped determined by vectors A, B, and C. So you take basically vector A, B, and C. So you have vector B here, you have vector C, you have vector A. Okay, so let's give small curl to vector A. So if you have vector A, then what is a parallelepiped? You basically extend this in the parallel way. Then you have then let me draw this part. So such an object is called parallelepiped. So here you have example of a parallelepiped here. So the volume of the parallelepiped is given by the triple product A dot B cross C. So we want to interpret triple product as the volume of this parallelepiped whose basically sides are determined by vector A, vector B, and vector C. So what is the volume? Volume of a parallelepiped by definition is base area times height, right? So now, what is the base? So base is gonna be, so this is your base, which is going to be A cross B cross C. So that is what your base is, right? So the area, so it's gonna be, let's call this area as A, and let the height be h. So volume is going to be A times h. So let's look at A first. So A is, because of the cross product, we have A equals to B cross C, right? In fact, it's length of B cross C. Now, if you take, so we want to basically see the height. If this angle is theta, then the height is given. So h is here. We want to find out what is height, right? So if this angle is theta, first of all, B cross C, what is the direction of B cross C? B cross C is going to be perpendicular. So if you use the right hand rule, you'll see that B cross C is given by this vector. Yeah. Let theta be the angle between B cross C and A. So then we get that the height is given by, so height is given by A sine theta, right? Length of A times sine theta. Why is that? Again, use trigonometry. So this is your height is, so opposite side. So if this angle is theta, this is the base, hypotenuse is length of side, length of vector A. So you have sine theta equals to length of vector A divided by, sorry, it will be cos theta, right? Not sine theta, my bad. So cos theta is going to be, cos theta is going to be length of A, hypotenuse divide, so bay, it will be adjacent side, which is h, divided by the hypotenuse, which is length of vector A. So we get height, this is my h, is going to be length of A cos theta. But now think about these two as vectors. So this is one vector and this is another vector, and then cos theta is the angle between them. So this is simply nothing but A dot B cross C. So here we get a convenient formula for basically finding the volume of the parallelepiped. Now, why are we using the absolute value sign? Because theta, cos theta could be negative, right? So in that case, we should put an absolute value sign because volume is positive. So this is your volume, V, and it's given by A times H, which actually translates to triple product. So we have proved that volume of this parallelepiped is equal to this triple product. Now, use the scalar triple product to determine if the following points lie in the same plane. So, if they lie in the same plane, then what can we say? So let's see P, suppose this is P, you have Q, you have Q, you have R, and you have this guy here. This will give you the, so if, and this is S, suppose. Now, if they lie in the same plane, that means S should have been here. Yeah, that would imply that the volume of the triple product, sorry, the volume of the parallelepiped should be zero, right? So we have the following result then. Yeah, does that make sense? So basically the idea is that the volume of the parallelepiped determined by these vectors will be zero. So, but the volume of the parallelepiped is basically the triple product. So we need to basically see, so the volume, so they are coplanar, that means they lie in the same plane. What are they? The points P, Q, R, S are coplanar if volume of the parallelepiped parallelepiped spanned by PQ, PR, and PS is equal to 0. That is in saying that the triple product, that means triple product of PS times, so PR or PQ times PR equals to 0. Yeah, so now we need to check what is this. So let's go back and find PQ. So what is PQ? So PQ is going to be Q minus P. So that is going to be 2 minus 1, which is 1. 4 minus 0, which is 4. 6 minus 1, which is 5. PR is going to be 3 minus 1, which is 2. Minus 1 minus 0, which is minus 1. 2 minus 1, which is 1. And PS is going to be 6 minus 1, which is 5. 2 minus 0, which is 2. And 8 minus 1, which is 7. So note that there is another interpretation of triple product. So we found out this is a triple product. Note that triple product can be written by A1, A2, A3, B1, B2, B3, C1, C2, C3. This is a direct way to compute the triple product. Yeah, it's not hard to see that. Why? Because let's compute this here. So we get A so let's see, A B cross C dot with vector A. This is going to be, first of all, you have A1, A2, A3. Then you have B cross C, which is IJK. So let's use IJK notation. AI, A1I plus A2J plus A3K dot with IJK B cross C, B1, B2, B3, C1, C2, C3. Yeah. So now when you take the dot product, you will see that this will be I will combine with I, you'll get A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. So this basically is an easy way to compute the, using determinants, you can compute the triple product. So now let's compute determinant of this. 1, 4, 5, 2, minus 1, 1, 5, 2, 7. Now we want to expand using determinants. So let's write it down. So it's going to be 1 times minus 7 minus 2 minus 4 times 14 minus 5 plus 5 times 4 plus 5. This is minus 14 minus 14 minus, so 14 minus, so minus 9, so 9 times, so 4 nines are 36 plus 5 times 9, which is 40. 5 nines are 45. So sorry, this is not 14, this is minus 7 minus 2, which is minus 9. That is going to be minus 45 plus 45, which is 0. So therefore, these points are indeed coplanar. Coplanar means they lie on the same plane. Okay. So co means together in that plane. Yeah. All right. So another nice, interesting application of cross product is, let P be a point not on the line L that passes through QR. So you have QR and you have a P which is not on this plane. So you have P. Then basically the distance D from point P to line L, generally that is given by a perpendicular, right? So this distance D, this is D, is given by A cross B divided by A, where A is QR and B is PQ. So let's construct this. So A is QR, so QR is here, and B is QP. So now what is QR times? So let's look at this guy here. Okay, so complete the parallelogram. So D becomes the height, right? So on one hand you have QR cross QP is equal to the area of the parallelogram, and on the other hand this is going to be D times, so it will be length of D, sorry, it's going to be D times, so the base, the length is, the height is given by D and the length of the base is length of QR, right? Area of a parallelogram is base into height. So the base is given by this and I'm completing the parallelogram. Let me just try to compute parallelogram properly so that it looks as a parallelogram. So this is your parallelogram. So on one hand, it's given by cross product. On the other hand, it's base into height. Base is QR, height is D, because it's a perpendicular from that point. So this implies QR, which is length of vector A, sorry, QR times QP, my bad, huh? Because it's QR times QP, this vector times this vector, right? Times B equals to D times QR, which is, so this is called as vector A, and this is called vector B in here, times length of vector A. This implies D equals to A cross B, length of vector. So that's one way of looking at it. Yeah. Now we can talk about orthogonal projection later on. Okay. So this is the setup, right? Now there is another physical significance of cross product, which is given by the torque. Okay. So suppose you have a force F acting on a rigid body, which is this body here. In this case, it's screw. And whose position vectors are. So idea is you're applying a force at this point on this rigid body. And this force at this point P, whose position vectors are, and you're acting the force on this body. Now the idea is that this force will produce a turning effect. And that turning effect is essentially what is called as torque. Okay. So basically, torque is defined as essentially if you have r is the position vector at which the point is acting, the force is acting, is given by r cross f. So this is the torque. So right. So it basically makes the object move around. Okay. So let's look at the following problem. A bolt is tightened by applying 40 Newton force to a 0.25 meter wrench as shown in the picture. Find the magnitude of torque about the center. So the idea is torque will act here in this direction, right? It will be basically inside the, if you imagine it's going to be inside this page. So find the magnitude of the torque. So magnitude of torque is easy to find. So it's R. So torque, magnitude of torque is take R cross F, magnitude of this. Now, generally you would have to know the angles and stuff, what R is and so on and so forth. But if you look, magnitude is easy to compute because this is going to be simply length of R times length of F, right? Or magnitude of F, that's the right way to see. After all, F is a vector, times the angle between them, which is what? The angle. So this is how the force is acting. You have position vector of this is R. The angle between them is 75 degree. So it's sine of 75 degrees. Yeah, actually I should do this as well, but sine of 75 degrees positive. So we get that is equal to 0.25 times force, which is 40 Newton, times sine of 75. So sine of 75 degrees. So this is the answer. And the units is given in Newton meter. So this is your magnitude of torque. And this will produce a, a pushing motion of the bolt inside the screen. So this is the idea behind the cross product. There's one more interesting thing I would like to talk about is I cross. So if you take vector I cross vector j, this is useful when you're doing computation. It is vector k. Vector j cross vector k is vector I. As long as you're moving in the cyclic, so I cross j would be k, right? So what is left out? So let's say, let me just write down k cross I, that will be vector j. Okay, so if you move in the cyclic order, you still get the positive. However, if you move in the opposite order, you get j cross I equals to minus k. Okay, similarly, k cross j is going to be minus I again, and so on. So you can think about quaternion structure there if you're interested. So thank you for your attention.